Welcome to the 14th lecture. We are studying total frequency response of a BJT amplifier. Before this, we have been studying low frequency response and high frequency response. So today we'll plot the complete Bode plot. This is the complete Bode plot for a BJT amplifier like this. This is a common emitter amplifier. It's a complete BJT amplifier. Today we have drawn in this figure the complete Bode plot for the amplifier. We see there are three cutoff frequencies on the lower side, FCL1, 2 and 3, and we know that the decay here is minus 20 dBs per decay. Here this is minus 40 and here it is minus 60 dBs per decay. Why do we have three cutoff frequencies? Because the decrease in voltage gain at lower frequencies is due to these coupling C1, C3 and bypass capacitor C2. Since we have three capacitors, therefore we have three RC networks and hence three cutoff frequencies. While on the higher side, we have two cutoff frequencies because of the junction capacitances CBE and CBC. CBC is solved using Miller and part of it is considered on the input side and the part of it on the output side. And hence we have two different RC networks, one on the input side, the other on the output side, and therefore we have two upper cutoff frequencies. Right. Today we are going to study what is a dominant frequency a dominant cutoff frequency. A dominant cutoff frequency is the frequency that is one of the three, the dominant FCL, the dominant FCL and a dominant FCU. A dominant FCL, lower cutoff frequency, the dominant cutoff lower cutoff frequency is the highest of the three lower cutoff frequencies. In this case, it is this frequency, the highest of the three lower cutoff frequencies, whereas the upper cutoff frequency is the lowest of the two upper cutoff frequencies. So we have three lower cutoff frequencies, two upper cutoff frequencies. So we have to select the dominant cutoff frequency, one dominant cutoff frequency on the lower side and one on the upper side. So the highest of the three lower cutoff frequencies is the dominant lower cutoff frequency, and the lowest of the upper cutoff frequencies is the dominant upper cutoff frequency. Right. So one more thing that we will study is that now this Bode plot can be simplified. It can be simplified and it can be drawn like this. So now we have one FCL that is dominant and one FCU and it is also dominant. This is the highest of these three and this is the lowest of these two. Right. So these dominant frequencies, they are also called half power frequency. The dominant frequency, any of the two, is also called half power frequency. Why do we call it half power? Because we know that at dominant frequency, the output voltage is 70.7% or 0.707 times the voltage gain that we have in the midband. So the output voltage V out at FCL or H is FCL or FCU is 0.707 times V out that we have during midband. This MIT stands for midband. So what should be the power then? What should be the power? We know that the power output at Fc would be, power can be written as V times I squared times R, or V squared over R. So this can be written as V out at Fc squared over R. V out can be written as 0.707 squared V out mid squared divided by R. So this term, point V out mid squared divided by R, is power out during midband, and 0.7 squared is 0.5. So the output power at Fc is half, or 0.5 times the power available during midband. So this power is half the power available in midband. So that is why any of the two, lower or upper cutoff frequency, they are also called half power frequency. This is half power frequency, this is also half power frequency. One other thing that we'll study in this lecture is bandwidth. Bandwidth is a range of frequencies between the upper and the lower cutoff frequencies, and they should be dominant. Fc upper dominant minus Fc lower dominant. So if we have this as the body plot, this is FCL, this is FCU. So this range of frequency is also called bandwidth. Bandwidth is represented by BW. BW. So this is also called bandwidth. And the last thing in today's lecture is the gain bandwidth product. Gain bandwidth product. It is the product of the gain with the bandwidth. And to understand it better, you have to study unity gain bandwidth first. Unity gain bandwidth is the bandwidth Ft that is the constant gain that we obtained using midband times the bandwidth. This is the bandwidth. This is the AV obtained during midband. So the product of these two, AV times bandwidth, AV mid times bandwidth, is the unity gain bandwidth. This means this is the maximum Ft. If we have, this can also be represented as this if we have AV mid. If we keep AV mid is equal to 1, this means 0 dB. If it is a 0 dB amplifier, so Ft would be 1 times bandwidth, means the bandwidth. 1 times bandwidth. So this is Ft is equal to the bandwidth. Ft represents the difference of the upper cutoff frequency dominant minus FCL dominant. So Ft becomes the difference of the upper cutoff frequency, dominant upper cutoff frequency, and dominant lower cutoff frequency. This upper dominant cutoff frequency is very small, a few hertz or a few hundred hertz. So if we assume FC upper dominant to be much larger than FCL dominant, the unity gain bandwidth Ft is equal to FCU dominant. This is the maximum frequency. This means this gives us the max frequency at which we can use this as an amplifier with 0 dB gain. But if we let AV to be 10 or 20 dBs, this means that AV is 10 here. This means Ft is 10 times bandwidth, or the bandwidth. This means Ft is 10 times the bandwidth. This means the actual bandwidth for which we can use this as an amplifier is Ft over 10. So this means that graphically, this means that if we are working with an amplifier with 0 dB gain, or having an amplifier having AV is equal to 1, we can operate it as an amplifier for a very long range of frequencies up to Ft. But if we are, on the other hand, if we are operating it at, let's write it here, over 10. If we are operating it as an amplifier with voltage gain is equal to 10, we cannot operate it for very long range of values or very long range of frequencies. So we will get the cutoff at a very smaller frequency equal to Ft over 10. So this product remains the same. This gain multiplied by this is the same as this gain multiplied by this. The answer is Ft in both cases. So if we have designed this amplifier at a higher gain, for a higher gain, AV is equal to 10, for example, if we have designed it for a higher gain, we cannot achieve larger bandwidth. But if we design it for a lower gain, we can have a larger bandwidth to operate. So it's a compromise. If you want to obtain a higher gain amplifier, an amplifier with high gain, you cannot have larger bandwidth. We have to work with smaller range of frequencies. The bandwidth is small. But if we want our bandwidth to be large, we have to make a compromise on gain. So it's a compromise. The product has to be the same. So if sometimes you need amplifiers with higher gain, so you compromise on the bandwidth, the range of frequencies. But if you don't want to make a compromise on the bandwidth, you have to compromise the gain. So lastly, we will be solving an example regarding unity gain bandwidth. Ft is given to be 175 megahertz. AV during midband is 50. So we have to find the bandwidth. It's simple because bandwidth is, we have just studied, bandwidth is Ft over AV mid, because Ft is AV mid times bandwidth. So this is Ft 175 meg over 50. So bandwidth comes out to be 3.5 megahertz. So you cannot go beyond 3.5 megahertz. So you can go beyond 3.5 megahertz if you compromise on gain. So if you want, for example, gain is equal to 10, you can go beyond 3.5 megahertz and still it will be working as an amplifier with constant gain. So larger gain means smaller bandwidth. Right, the problem has one more part. That's part A. Part B is that for an amplifier we have upper cutoff frequency given to be 25 kilohertz. So with a small range, FCL is 100 hertz. So the bandwidth is already very small, 25 kilohertz minus 100 hertz. So you have to find the bandwidth. That is FCU minus FCL. 25 kilohertz minus 0.1 kilohertz. 24.9 kilohertz. And then we have a homework for students. FT FT is given to be 130 megahertz and bandwidth is 50 megahertz. What should be AV made? It's a homework for students. Right. That's all for this lecture. And in the next lecture, we'll study frequency response of frequency response of multi-stage amplifiers and multi-stage BJT amplifiers, in fact. Thank you.